All right, so transformation is sort of a new thing that we haven't looked at before, but we can actually change the orientation and size and position of the canvas itself. So for everything that we've been doing this semester, we're always using the top left corner as sort of the origin point of the canvas. But we can actually change how that orientation works in P5. And so let's start by just looking at translate. So all of these different functions fall under sort of the transformation family. So if I click on translate, we'll see translate here. And you can see the syntax. So for 2D, we're just going to be using translate XY. And so we can translate the origin of our canvas to a different position. And so it's kind of simple, but it lets us do a lot of cool things. So these are some basic examples with some hard-coded numbers and this animated one. But if we look at the reference and go to transform, that's where you're going to find the functions that we're going to be talking about today under transform here. Oops. So rotate, scale, translate, and shear. And all of these apply different transformations to the canvas. So I'm going to do a quick example of what this would look like. And then we'll look at some more examples. So if I draw an ellipse at 0, 0, and let's do 100 pixels, we see that the origin of the ellipse is that top left corner of the canvas, like we've been doing all semester. And I can actually move the ellipse without changing any of the values in the ellipse if I translate the canvas itself. So I can say translate, and I could translate to 200, 200. And so that's halfway across and halfway down in the canvas. And so now the origin point for my canvas is actually in the middle, as opposed to the top left. And so I can reorient the canvas and use new values based on that. So for example, now I can actually say an ellipse at negative 100, which before that would have just been outside of the canvas. Now, since we translated 0, 0 to the middle, now an ellipse at negative 100 is actually, just on the left side of the canvas. And so this doesn't really change anything about the way that the canvas works, but it might be easier to do certain types of calculations if the origin or the center of the canvas is in the middle, visually. And translations only apply to things that come after the translation. So if I draw another ellipse at 0, 0, that first ellipse is still in the top left corner because I haven't applied this translation yet. And I can apply multiple translations to the canvas. The translate and transformation functions are more performance heavy than some of the drawing functions. So if you use like a ton of them, you'll start to see a little bit of a slowdown. But using a few of them is not a big deal. So if I translate again, it's going to be additive. So let's actually group these guys. So I'm going to put this ellipse back at 0, 0. And so if I translate again, this time I'll translate 100 over on X, and I'll go negative 100 on Y. So we're actually going to move farther right, but then back up. If I draw another ellipse at 0, 0, you can see that we've translated, 100 over on X. So the origin has gone from here to here, and then negative 100 up. So the translations will add together if we add multiple translate functions. So here's an interactive example of how this works. So we see translate is at XY. This rectangle is 10, 10, 50, 50. And the ellipse is at 100, 100. And as I translate the origin, so you see the top left still shows where it would have started. but we're just moving 0, 0 around on the canvas. And you can translate wherever you want and however many times you want. But typically, what it's usually used for most often is just to set the 0, 0 point in the middle of the canvas, because it makes it easier to do certain types of things. Especially we'll see in conjunction with other transformations like rotation and scale. That makes it much easier. It makes it much easier to use those functions if we're moving the origin and then doing the rotation. So that'll make sense in a second. Okay, so rotate. So this is something you guys might have thought, how can I, rotate this shape or rotate this image or something like that as you're working on something? And the easiest way to do it is using a rotate function, which is another transformation. And so rotate just takes an angle. There's an optional axis for 3D, but we're working in 2D, so we don't have to worry about that. So the angle is just how far we want to rotate around. And this is where translate is going to get really useful. Let's look at an example, and then we'll write some code. So in this example, we have the same shapes, and we can translate them. Okay, but notice that when we rotate, the rotation always happens around the origin. Okay, so if I leave my origin at 0, 0 and I rotate, notice that circle is mostly off the canvas, right? Because we're really far away from the origin. So as we rotate, we're rotating with the same distance. Whereas the rectangle, rotates nicely around that origin point. So if we translate first and then rotate, we can do an animation using our rotation. So let's add this in. So with an ellipse, we can't really show the rotation very easily because it's a circle. So we'll move it. We'll add a different shape. So I'm going to translate first, and I'll translate to 200, 200. You could also say width over 2, height over 2. You'll see this a lot in a lot of different sketches if we want to put something in the middle of our canvas. And now I'm going to draw a rectangle so we can see the rotation a bit more easily. And so if I put my rectangle at 0, 0, and I'll do 100 for the width and height. So since we've translated to the middle of the canvas and the rectangle is drawn from the top left, we see the rectangle is drawing from there. If we want to put it directly in the middle, we can change the rect mode to center. Okay, so now the middle of the rectangle is 0, 0, and the canvas is in the middle. And so now if I apply a rotation, we'll see that rectangle rotate. So I have to translate first. So if I say rotate, rotations are measured in angles, which go between 0 and pi, or a full rotation is 2 pi. So remember, pi is just a constant that's used for calculating angles. So if I rotate, you can rotate by numbers too. Like if I rotate 1, that's some value. If I rotate 3, that's some other value. But if you want to rotate, with precision, we have to use pi. So if I rotate by pi, you can't see the difference because it's a symmetrical shape. If I rotate by pi over 2, same thing. If I rotate by pi over 4, now you see I've done a quarter, or is that no, that's an eighth of a rotation. So actually, let's not put our rectangle in the center. It'll be easier to see. Yeah. Okay, so if I rotate by pi, we rotate half of a circle. If I rotate by pi times 2, we're back to where we started. If we rotate pi over 2, that's half a rotation. Pi over 4 is a quarter rotation. Pi over 8 is an eighth of a rotation. So we can rotate between pi and 2 pi. So if we rotate before we translate, so I'll put this at pi over 4. Now look, if we rotate before we translate, so I'm going to copy this and put it up here, it's going to do the rotation first before the translation. So our square ends up all the way down here because we rotated the square and then we translated the whole canvas. So that's where transformations can get kind of tricky. If I take out this translate, you'll see the square is just rotating around the origin. And so once I do the rotation, my origin is actually facing a different direction, right? So let's actually, so my origin starts at 0, 0. And if I translate x, but if I rotate the origin down here, then if I translate x, now x is actually going down. So that's where adding transformations together can get really confusing. But you can avoid that for the most part. So now if I translate 200 on x, 0 on y, so we move like down and to the side. Let's actually just rotate pi over 2. We can't see if we do that. Okay, let's stick with pi over 4. So if I hadn't rotated, I would have just moved straight to the right on x. If I rotate, then my whole canvas is rotated. So when I translate, x is actually moving down to the right. So it gets a little confusing. Mainly, simple trick is just to translate before you rotate. So I want to translate to the middle of the canvas before I rotate my shape. And rotations are also cumulative. So let's say if I rotate pi over 8, so 1/16 of a rotation. And I draw a rectangle, and then I do it again. And I'm just going to draw the same rectangle, 0, 0, 100, 100. Everything is the same. So notice the second rectangle is rotated twice. So the rotations are cumulative, just like our translations. Any questions? Okay, cool. So let's keep going. So there's some built-in values for pi, actually. There's just pi. I tend to just use pi and then like whatever, multiply by 2 or divide by 5 or whatever. But you can actually use pi is just, half a circle. Half pi is a quarter circle. 2 pi is a full circle. Quarter pi is an eighth of a circle. I think that's all of them. So those are probably better for performance because you're doing less calculations, but obviously writing just like pi divided by 4 is easier. So that's what I usually do. All right, so the next thing we do is scale. This is another one where it's useful to translate before you scale. So let's look at the difference of this one as well. So here we have translate xy to 0, 0, and if we scale, we're scaling directly into that point. So we're scaling towards the center of our canvas. If I translate back to 0, 0, now when I'm scaling to the top left. And it's doing the same thing ultimately, but I think conceptually it makes more sense for us when we're scaling to the middle visually than when we're scaling to the corner. So if I want to add in a scale, I can, the scale and the rotate won't affect each other as much. Like if I translate and then I scale, I'm going to be scaling into the point where I translate. But if I rotate after I scale, it doesn't really matter as much. So I'll put the scale after rotate, and we can scale by 2. And so it just makes everything twice as big. Obviously, if I keep going, scale by 4, works the same way. I can also scale down. If I scale 0.5, get smaller. I don't know how small I can scale. I guess not that small. I can kind of see it in there. So I can scale pretty small. But let's leave scale at 2. So those are the kind of 3 basic ones. There's another one that we'll look at in a second that's a little more confusing, but we'll stick with this for just a second more. So that's scale. Oh, okay, shear. So I guess we'll do this before we do some animation. So these ones are all pretty straightforward. The one that's probably the trickiest to understand is shear. So I have a couple examples of how this works. So shear is applying a transformation based on an angle. And so this is kind of a rudimentary example of how this works, where you can see the shear angle, and this is shear x. There's shear x and there's shear y. So if I do shear x, I'm creating an angle that basically pushes all of the points of my shape away from the center. So it's kind of hard to explain, but you can see the angle here. And essentially what shear is doing is as you get away from the center point, it's moving everything over by that angle. And so you can use this to get some cool effects. So if I translate after I shear, I'm moving kind of across that x-axis and down that y-axis. And I can shear like all the way around until I'm back to normal. And so this is how you can get some kind of some cool effects. This one is kind of harder to understand what it's going to look like, but you can do some interesting stuff with it. So shear y does the same thing, except it's pushing the things away, the points away on the y-axis. And then you're going to translate across. I don't know why this is. Try reloading this. So yeah, then you're going to translate across this axis as well. So that might be good for, you know, making some isometric style drawings or doing different things with animations. So let's take a look at this and then we'll go back to our code. So this is an animation using shear, right? This is actually interactive, where I'm mapping the x value to shear x, and then the y value to shear y. And so you can see there's some kind of, you know, you can get some cool transformations with the different shapes. All right, so let's add some animation. Let's go back to, wait, let me see. Okay, so we can go over push and pop, and then we'll do animation. Okay, so push and pop are useful functions for doing multiple transformations that don't affect each other. And when we go over building patterns, this will be even more useful. But basically, here we have 2 different translations, and they don't affect each other. And the reason is because we're using push and pop. So if we want to have something like that, let's set up a couple of things. So we have our rectangle here. Let's say we want to leave that there, but we want to create another part of our design with the original translation. So what I could do is I could do a negative translation. I could translate negative 200, negative 200, and I could rotate negative pi over 4. I'm just showing what is not what we want to do. And then I could scale down by 0.5. And now if I draw a rectangle, looks like that didn't even work. So let's try. Oh, I'd have to undo my things in the opposite order that I did them, I think. anyway, the point is that this is not easy to do. So I'd have to unscale first, 0.5. Okay, then I'd have to unrotate, negative pi over 4. And then I would have to untranslate, translate negative 200, 200. Oh, I did regular. Okay, so obviously that's silly. I don't want to like undo all the transformations I already did. So another thing that I can do is use push and pop. And I can do this as many times as I need to have different transformations. And it's a bit hard to explain how this works, but basically with push and pop, you have like a list that P5 keeps track for you. And let's see if I have is there a paintbrush on here? Yeah, here we go. Okay. So let's imagine I have this like list, and there's like the first transformation. So it's like 0, 0. I'm really bad at drawing with that mouse. Okay. Okay. Where's the pencil? Okay. So I have a list, and the first transformation on my list is 0, 0. And no rotation, 0 rotation, 1 on the scale, whatever. So if I push, I'm going to add this to my list, and then I can do some other transformations. So I'm going to translate 200, 200. Wow, this looks awful. I'm just going to give up on this. Okay, let's imagine I have a list. I'll do one up here in my comments. So in my list, I have my first translation is 0, 0, 0 for the rotation, and 1 for the scale. And then when I translate, it turns into 200, 200, pi over 4, and 2. So if I just do that translation, it just like does it. It doesn't save it anywhere. But if I use push and pop, so what I can do is I can push this transformation to my list, and then if I pop, it'll remove it. And so I can do that. The reason it's done that way is so I could do a bunch of transformations and then remove them. But we're probably just going to do it one at a time. So the way this looks is before I do my transformation, I write push. That adds my transformation to the list. Then anything that goes in between this push and the next either push or pop is part of that transformation. So if I say pop, it releases, it goes back to the transformation before that. So now my rectangle goes back to the origin without me doing any other transformations. So this, you can use these as many times as you want. So for example, if I say push again here, now the scale part is still there. So when I pop, I'm only popping the translate and the rotate. And if I pop again, oops, then I'm going to pop off the scale as well. Okay, so it's a little bit tricky to use them, but the majority of the time you use these functions, what's going to happen is you're just going to do push, do some translations, pop, and then go back to where you were. And you could do that multiple times. So if I wanted to use this to like move my rectangle to different places, I can just do push pop and just keep my transformations in between the two of them. We probably won't use that one too much for now, but when we do patterns, it'll be useful. Okay, so now let's do some animation. So we already looked at how to do animation with the position and the color and stuff like that, but for doing things like rotation or scaling, using transformations is going to be a lot more effective. So let's do a couple animations using our rotations and scaling. So I'm going to get rid of this stuff. I want to get my image and my text back in here. So let me go. Did I save my images anywhere? Downloads. No. Okay. So let me open a new window and just grab some of my old code. I think logic example 3 is what I want. Yeah. Okay. So let's grab that image. So I'm gonna download this cat.png. Oh, is it gonna let me download? No, I can't. Okay. Let's just copy this sketch then. That'll be easier. And I'll just delete the code here. So I'm gonna duplicate this sketch. And I'll call this animation example 3. And so we can leave all of this stuff the same, but I'm just going to do one text. So I'm going to delete all this stuff that we had before. And I'm going to get rid of these extra images. So I'll just have my cat image. And I don't need this counter anymore. Okay. And I don't need the mouse press. Let's get rid of that. And I don't need these variables anymore. Okay, we're back to normal. Okay, so the first thing I want to do is do a rotation. And just like with the animations we looked at on Monday, I need a variable to do this because if I need a value that changes but doesn't get reset, I need a variable that exists outside of my draw function. So I'm going to use a variable for the rotation. I'm going to say variable r and set it equal to 0. And so now I'm going to have to change some of the stuff in my image the way it's set up to make this work. So the first thing I'm going to do is translate to width divided by 2, height divided by 2. So I'll translate to the middle of my canvas. So immediately we see that the image is in the wrong place and the text is in the wrong place because the image is being drawn from the top left and we're drawing this text at width over 2, height over 2. So it's easy to fix the text, right? We've already translated to width over 2, height over 2. So to draw the text there, we just put the text at 0, 0. So that's easy enough to do. Then with our cat image, we're drawing the image from the top left. So let's reset, let's say image mode is center. And I'm putting this in setup because I'm not going to change it. So I can just put it up there and do it once and not have to worry about it anymore. Okay, so when we translate, we have to draw everything from 0, 0, or not necessarily, but most likely you're going to be drawing stuff from 0, 0 instead of like 200, 200 or whatever. So it's a little bit of a different way of thinking about stuff. Does that make sense? Maybe? Maybe not? All right. So let's rotate our text. So I'm already translated. I'm going to put all this text stuff in setup too, actually, so we don't have to look at it because I'm not going to change it. Okay. Okay, so let's rotate. I'm going to rotate. And if I rotate by like pi divided by 8 or whatever, we'll see the text gets rotated. Okay, that looks kind of cool. But again, this is a hard-coded number, so it can't change. So what I really want to do is rotate by r, and then my sketch will update if I change r. So now let's change r. So I can say r plus equals, and here it's like I could put a really small number. Rotation angles are small numbers, or I can use pi. I could say like pi divided by, but if I say pi over like 4 or 8, it's going to go really fast because that's like a big angle. Actually, that's not too bad. That's kind of funny. But I probably want more like pi over 16, pi over 32, something like that. Pi over 64. Or you can just use a small number. So if I'm like 0.1, that's not bad. 0.1 0.05 or something like that. Might be right. So either way, remember the angle is a small number. It's going to be less than 6 because 2 pi, one rotation is 2 pi, which is like 6.28 something something. So your rotation value for the animation is going to need to be much smaller than that. Like if I rotate by 1 every frame, it's going to go crazy. And you know, maybe that's cool. I don't know. Let's do 0.5. So then my text is rotating. I have the text aligned center. Let's change it to center. So it's rotating from the middle. And yeah, so now I have the text rotating. So the nice thing about the rotation also is I can throw shear X in here and it's gonna do the same thing because it's also based on a rotation. So that's another kind of cool effect. We can do shear X or we can do rotate. If I do both, let's see what happens. Looks kind of crazy. And I could, let's rotate by half of what I'm shearing by. Or no, let's shear by half of what I'm rotating by. Or maybe even, yeah, that's kind of cool. Anyway, you can combine it and get different effects with rotate and shear. Let's see what shear Y looks like, just for the heck of it. Oh, that's kind of cool. Okay. So let's do one more animation and then we'll be done. So if I want to animate the scale to like zoom in, we can do that with the image. So if I scale, let's say I scale by 2 before the image, I'm going to scale into everything. Okay, so you may want that, you may not want that. If I don't want to scale into everything, what I need to do is push before I scale and then pop after I scale. Okay, so remember if I put the push before the translate, now the translate will get popped. So now my text goes back to the top left corner. So the order of these things is, you know, important. Okay, so now let's animate our scale. So let's use variable s equals 1 for scale. I already have s for the string. I'm a cat, so let's use scale as a function. So I can't say scale. So I'll say image scale, and I'll set it at 1. So now I'm going to scale image scale, and now I'll animate it by incrementing it. So I'll say image scale plus equals. So again, if I do 1, it's going to go really fast because scaling by 1, like, you know, scaling by each multiple is going to go really fast. So that's too fast. So let's scale by like 0.1. See how that looks. That's still pretty fast. So let's do 0.01. Okay, that's pretty good. And then with the scale, our rotation can just keep going forever because it's just going in a circle. But the scale, it's like eventually, you know, we want to probably go back, right? So we can do the same thing with the speed that we did with our bouncing DVD logo with our scale. So remember, to do that, we need another variable. So let's say variable scale speed, and let's start with whatever we just had, 0.01. And we can see if the scale speed gets if the scale gets too large, then we just scale back down. So if image scale is greater than, let's say 4, that should be good. But so if we say image scale is greater than 4, then we'll change the image, the scale speed. Is that what I called it? Yeah. So I'll copy that. And I have to actually use it. So let's replace our speed value here. So we'll say scale speed. And remember, we can reverse it just by multiplying it by -1. So it's the same thing we did with our DVD. So we're going to zoom in. And at a certain point, maybe 4 is too much, we're going to zoom out. Let's do 3 instead. But then it's going to scale down forever. And eventually it inverses if you do a negative scale, which we don't. I mean, maybe that's cool. Maybe you want that, but it's going to go forever. So we also need to catch it when it gets too small. So I'm going to say if image scale is greater than 3, or remember our double pipes or lines, image scale is less than, let's say, 0.1. So now it's going to zoom in. Although I guess we want to do 1 if we don't want to zoom. So yeah, that actually looks kind of cool. So you might want to keep that, but I'm going to do 1 so it goes back to where it started. And so then it'll just keep going. It's kind of subtle, but you can see that the performance on this sketch is not as good as the performance of the DVD sketch because it's doing all these transformations that are much heavier for the graphics card on the computer to calculate. Like it's calculating where all these different pixels should be as we're like transforming and doing all these rotations and stuff. So this style of animation, the performance isn't going to be as good as the animations that we did on Monday. But this isn't too bad. If it got a lot more complicated, it would probably start to look bad. Not that this looks not bad in the sense of aesthetics, but in the sense of performance. But yeah, that's the basic idea. Let me see if there's any other things to cover. No, I think that's it. Um, so I'm going to save this. I'll share these examples and post the video. Let me stop recording.